Good morning, good afternoon, or good evening, depending upon where you live around the world. In my efforts to better understand what the heck I'm doing, I've said in other videos many times that I'll sometimes go down a pathway or an avenue of thought and exploration to wind up with no positive outcome. You could look at it the other way of saying, well, every failure was a positive in that I don't have to look at it anymore and I've eliminated one of those avenues. You could say that. Often in my contemplations, I'll actually make the comment that for my purposes, I think that the Viking Dome's star plate or equivalent is one of the more elegant hub joint systems. I like the look of it, and if it were suited to my situation, I'd possibly look at it, but I wanted to be able to create something in my workshop without specialist tools. So that is why I went down the steel tube center hub side of it, because I could, after purchasing the length of pipe, cut it to the required lengths in my workshop, and I don't have to have any specialist tool. Now, yes, a cold cut system like a drop saw or bandsaw for metal would be ideal. I don't have those. Could I purchase them? Yes. Will I? Likely not. But I can still cut the hubs to size using simple tools and methods. And I kept on saying the star plate looks good. And then but in my situation it was going to be quite complicated, and if I adjust things, which is very, very likely down the track, then having a template for said star plate or the particular file for a laser cutting company, it might change and cause me all sorts of grief. So again, I was bleating on about how clever my hub system was for being able to be adjusted almost on the fly. So you could get out onto site and, if necessary, adjust it in some manner, where you couldn't do that with other systems, and other system for hubs can sometimes self-misalign. Not good. So what have we got here? Well, we've got one of the most basic hub systems that you could come across. I've seen a lot of these being built, and the photos at least, and I kind of like the idea of it, but then kind of didn't. But I've re-looked at it simply for the investigation, and it's interesting. I couldn't ask for a more simple hub type construction. A little bit fiddly when it comes to do different aspects of it, which we'll discuss very shortly, and that could be its limiting factor, but I'm sure with some thought it could be resolved, says I. All this is in this case 45mm wide strips of bar stock that can be cut to, let's say, 250mm lengths, and in a jig bent at the same place all around. So you could have these strips simply cut, rounded off if you want, which I probably would, and as I said, in a jig, to make sure that the bend is in the same place, tip the particular strips over to the required angles as you've determined within the SketchUp drawings, which we have that angle already because it was aspects of the construction of the honeycomb and the angles of the dome structure. And then you can rebate the timbers depending upon where the strips get mounted one on top of each other. Now, the ones I've seen, they've only used a single strip. They either do what I've done here, rebate it slightly, or they, more common, they'll insert it into the timber. So there'll be a point at which, say this one is at or near the center, and the rest would generate out. Now, to be fair, the ones I've seen don't normally do that. They seem to split the timber, rather create the cut at the same point. Some do, not all, but some. And then therefore these struts will never be at their correct height geometrically. They simply can't, because you're being offset by whatever the multiple of the thickness of the plate would be. Others I have seen where they have grooved the strut at different heights, as I've done here, and have had at it. You know, they've assembled it, and that would keep the tops of the struts in their geometrically correct place or close to. This does it in probably a little bit more thorough a fashion, I suggest, but it's interesting, put it that way. Now, being 3mm, that's actually quite a solid piece of steel. And the wider you get, the more difficult, and that's it is to bend accurately. But as I said, in a jig, where you would entrap this piece in the jig itself, you can put the a hole through the jig and insert your straight strip. This would want to be a piece of steel that is gauged for this thickness, and then a corresponding piece of steel assembled so that it would trap the tab, and then when you bend it over you get a nice fold line. If not, if you don't do that, it will round, which is not a problem in itself. You would have a round in this area rather than a fold line, and it wouldn't be consistent. I know that now because, trust me, been around engineers. I've done this sort of thing before, and consistency is an issue. But having a folding method or process is beneficial. Now, I've just represented bolts here. I'd probably have a domed, like a coach bolt, rather than a engineer's bolt. But you could easily insert the bolts that then can go right through the strut. And in this scenario, I have a lower assembly of the same type. So you could, and this is one of those, you could say an issue of alignment. The bolt hole, if you were to pre-drill it in this top assembly, won't be the exact same place on the bottom assembly, because it's not. And you can actually see it effectively there. This assembly here has just been lowered, but you can see where it extends here compared to the end, so it effectively changes position. So drilling down through that area there and trying to get it to line up may be a little bit of a process. May be able to be done. I can be wrong. I haven't really looked at this one a great deal, but it does have that ability. If these tabs are inserted into the struts in the workshop in a jig, it means that we can drill down with a good portable drill. I'm going to say press, it's not, but I've got one. I bought one just recently that does very accurate plunge of the drill, and I can see that working. Having not done it before, I could be wrong. But all we've done there is here at the moment, is that I know this is 3mm thick, the tab, so I've rebaited this strut down 3mm, so it's actually relative to each other, this moves 0. This one is underneath, so it's down 3, down 6, down 9, down 12. And then it would be 15, 18 for the 6-point hub. So this is actually it's not pretty, but it's reasonably, well, it's very simple, self-aligning, because you have made a jig up to take these components as you're making them. With an inclinometer, a magnetic one, you could quite easily put it on the bending part of the jig, and as you tip it over you can get the correct angle for this particular one quite easily. Go to the next one, set it up, with your bending list what you need here, so you can bend it over with the inclinometer on the jig assembly. So, and as I said, this one has a balancing assembly on the bottom, tied together with just a bit of, in this case, 25mm water pipe, just to stabilize the whole joint. Will that work? No idea. Well, it will work, but is it strong enough for my demands, for my paranoia? Don't know. Can this be used in combination? Well, the question is, why would you bother? And in combination, I'm meaning a ring in the bottom with the threaded rod and pipe assembly. I don't think I would combine I wouldn't make it a hybrid. I'd think that if you're going to do this or make this assembly, you would make it top and bottom like this. The big thing is, it's cheap. No specialist tools, no specialist manufacturer, and if you make a mistake, you can quite easily counter it with another of these tabs bent up quite readily in the workshop again. I like it. It's the cheap man's star plate. It has advantages over the star plate, but its big detraction is looks. But I'm sure that if you're underneath the dome and you're seeing this sort of assembly, you might not be complaining too much. I'll have to give it some thought, because as I say, the engineers, I certainly apologise when I make a statement which falls outside my wheelhouse and into the engineers arena, but from lack of knowledge, I have to make a guess, and I guess this is a stable assembly because it's a incorrect way of saying, but double shear. It has a balanced load path because it's top and bottom, so I don't have the issues of high load, which would probably, if most of it would be this assembly. As I said, the lower assembly should in theory be the one that's loaded the most, so this assembly should take precedence over this one, whereas most of the systems, as I mentioned, are a single assembly placed in the or near the neutral axis of the strut members, because I want and need a stronger assembly in this very position of the dome, this here, and here. These two joints are the ones that need the most strength and stability, because there is nothing else supporting them, and all their strength comes from the hub. Up here it's different. It's back to the geodesic, the benefits of a geodesic system, where you've got self-triangulating, self-bracing sort effectively assemblies. Here you're missing them. You haven't got those other triangles and struts assemblies to stabilize this. Strong, yes. Stable, unsure. Here, hinging, this has got that hinging risk, even though it is in a braced angle with opposed equivalent leg over the other corner. It is not inherently stable. These are, these aren't. This isn't, this is, sort of thing. So you can see my at least my thinking, even if it's all up the thingy. But top and bottom. Here's the other thing. Because the bolts are in shear, it may well be that I don't have a through bolt, but rather a bolt going down, or a timber screw going down into the top surface, but at an offset coming up through the bottom into the timber, with the screws offset to each other. That then would allow, as I'm thinking on the fly here, the pair of these tabs, in fact this one as well, but the pair of tabs can be pre-drilled, because they'll be offset when put in place, or something. So this was a early period of, let's have a look at it, so we can come up with the problems, even if they're only imaginary in my own mind. Do I like it? If we can deal with that, if we make the gap between the two assembly slightly smaller, we could possibly recess the tabs into timber so that there's timber seen all the time, or we don't worry about it too much. I think it won't be an overly ugly assembly. I'm just trying to imagine what that would be like. I don't think that would be too ugly. And cheap and simple. Bit like me. Whew. Okay, that's it. I'll wander off. I might do a little bit more work on this in other areas and see what it looks like, and whether we can come up with any thoughts. So, it's got its appeal, doesn't it? Probably why the other people that have chosen this method chose it. There's certain elegance in its simplicity. Okay, I'm going to wander off, have a little bit more of a look at this, do some work outside, because it's going to be stinking hot today and tomorrow, and then rain. So this really can be put on the back burner for a wee while, and I better get outside. And with that little bit of knowledge that you didn't need to know, I'll bid you goodbye, and I'll see you in the next one. Okay, see you now. Bye.